people trickling in, but I think they'll be okay. So welcome everybody, and really excited for you to join us on this webinar for how to build agent-native applications with CoAgents and LangGraph. So first, would also invite you to join our community on Discord. So there's going to be an invite sent after this webinar. There's a lot of really great folks there, and we try to keep it pretty active, answer questions promptly. So always a good place to have. Some quick notes on the agenda for the webinar today. So first, we'll talk a little bit about the agent native era that is really that we've shifted into, which is, I think, kind of the first promise of AI starting to deliver on the promise of AI in real applications, which is extremely exciting. Then we'll do a CoAgents deep dive just to kind of get us, basic understanding of how CoAgents works, what are the features, but really we'll kind of skip really quickly through that through a demo. So to see it actually working, and then to actually build that application, essentially from scratch live, and you see it really takes a few minutes to do that. Yeah, so that's the plan. Any questions from anybody, either in chat or you can also, I think, raise your hand if you need to, if you want to. All right, so without further ado, let's keep going. So the agent native era. I think over the last few months, we've seen the emergence of new type of agent native applications. So you can think of the Replit AI agent, for example, the new v0.dev, and to some extent, the new OpenAI canvas. And these are agent native applications that actually work, right? These are not just promise, not just hype. It's actually delivering on the promise of AI applications for usefully automating the menial parts of human labor, which is extremely exciting. That's, I think, what's the biggest driving force around this whole revolution is, and it's actually starting to happen. And by the way, I think there's an interesting observation here where we're seeing developer tools pioneering these patterns. And we saw this before with the first wave of applications as well, where engineers first built for engineers, and the patterns that become popular in engineering tools 1 or 2 years later go mainstream into every single type of application. And that's what I'm personally very excited about. What does the Replit AI agent of insurance software looks like? What does the Replit AI agent of tax planning software looks like, right? How can we actually automate a lot of the menial parts of these jobs and really amplify whoever is working on these things? And so the really big deal about these agent native applications is they combine two themes. The first theme is you really handcraft the agent, right? We're not just throwing a prompt and kind of hoping for the best for it to figure out. We're breaking down a problem into a bunch of sub-steps that we as domain experts or programmers build into the agent. And then every single sub-step is really optimized on its own. And the prompt there is really carefully engineered with all the context. You give it really precise instructions. And so that's one part of why these agent-native applications work. And of course, that's where frameworks like LangGraph really shine, right? They let you handcraft the agent. It's not just a single prompt and it goes. But the second really important thing about these agent applications is the fact that they're applications, right? There's a really tight human-in-the-loop flow between the agent and the human user. Because these systems are at a place where, yeah, you can have a great demo with a thing just working on its own, but realistically, you're not going to get something that you're happy actually shipping. And so, it's not something you actually use in practice. But if you have a human-in-the-loop flow inside of an application, you can have this iteration back and forth alongside the agent that actually does result in really great output. And that's where really in the market we've seen the biggest product market fit for AI native applications is these human-in-the-loop systems versus fully autonomous systems. And it's, if you're building these types of systems, it's almost like you're building a virtual colleague for your users, which is, I think, a really cool abstraction of thinking about this. And this is really where CoAgents, Copilotkit's new CoAgents extension comes in. So as you guys in the webinar probably know, last week, after some incubation time with early adopters, we were really happy to introduce the public beta of our new CoAgents extension, which is essentially everything you need to deeply integrate a LangGraph agent inside your application, and really build, best-in-class agent-native applications of the kind that, you might think only the most hardcore engineering teams can do, like the Replit team, the Vercel team. But actually, as I'll show you, anybody can build these systems now by using, our CoAgents extension in LangGraph. It's really, this is going to become commoditized, and the expertise in the domain is actually what's going to shine. So yeah, without further ado, let's dive into CoAgents and how all that works. So the feature.
Want to pause for questions real quick or comments? Does anyone
Yeah,
have anything about like the design pattern and everything that I just mentioned?
Yeah, design pattern slowly congealing around this setup. Yeah, absolutely. Yeah, no, you guys, by the way, Uli's gonna monitor the chat the whole time. So if you have questions or anything, just feel free to jump in here. And actually, I'm also realizing we kind of skipped the introductions here. So let me kind of backtrack a little bit and do a late introduction. I'm Matai, CEO and co-founder of Copilotkit. And joining me here is Uli, my co-founder at Copilotkit. And yeah, very happy to guys be here. So anyways, kind of continuing where we left off. The CoAgents has we kind of aggregate the features around two categories. There are the in-chat experiences, and then there are the in-app experiences. And both of these are extremely important. So first, let's start with the in-chat experiences. The first abstraction that really kind of took off with AI is, of course, ChatGPT with this chat abstraction. And a lot of people thought maybe this is a temporary step in the UX, and then we're going to go to much more native, buttons and things like that. And of course, that is happening to some extent. But I think what we've seen in the last couple of years is actually the chat abstraction is actually very, very robust. And the reason is, if you think about it, what's happening right now in this webinar, to some extent, is actually chat, right? It's open-ended communication of ideas with language. And so I think this part is really robust. And whether it's going to be literally chat with text, or if it's going to be, voice or video, I think that's a bit more of an implementation detail that's going to evolve over time. But the abstraction of you have a way to actually communicate open-ended ideas with language, I think is actually very robust and kind of here to stay with us. And so in CoAgents, we kind of provide everything you need for this agent native chat experience. So first, you just have the text part, right? That just works. One line of code, you can text with a LangGraph agent. Great. That's kind of that in itself is actually not that easy to necessarily implement, but now that's one line, so that's great. One of the other things we introduced is what we call agentic generative UI. So this is in addition to the more traditional generative UI that which is more based on a tool calling abstraction. Agentic generative UI is actually rendering the agent's state as it's working, which is really important. Agents have one more piece of information that they handle, which is the state. So you can show the user what the agent is doing, build trust, and soon also have things like agent steering, which we're building on. So if the user see the agent kind of went on the wrong trail, they can bring them back on. And then lastly, there's really easy human-in-the-loop capabilities in the chat, right? So the agent can propose a plan to the user can review it, edit it, and like bring it back, for example. That's an example of human-in-the-loop paradigm, and just generally actively checking back with the user. And this is, again, very trivial one line of code essentially right now. So that's in chat. Now, as important is in-app experience, right? This is not just a chatbot. This is not just an application. It's an application with a virtual colleague. And in the in-app experience, one of the things we give is front-end actions access to the agent. So all the actions that you can define in the front-end application with Copilot OS, which is what we kind of had before Copilot, the CoAgents extension, are available now to the agent to interact with as well, which is really exciting. And it's actually not just front-end. I'm kind of trying to simplify it, but it's front-end, back-end, and other types of applications that are based on the real-time user state. One of the most exciting things is actually shared state, full shared state between the agent and the application. So everything the agent can do everything that agent can see, the application can see, and vice versa, which means these are actually not two distinct systems anymore. And finally, you can also have human loop in the native application. It doesn't have to be through the chat. And so these are the kind of basic features of CoAgents. So without further ado, let's go into the demo. Before I actually go, is there any questions that I can answer? I see here, what exactly are remote actions and why are they limited? And how does that affect my agents? So remote actions are just actions that are defined on any arbitrary server. Thank you for the question, by the way. Great question. And it's just, it's essentially infrastructure that allows you to distribute where the work happens to be other computers than the one that's actually literally running the agent. So this is, you don't get new net capability, but in practice, you actually do often want to run things on different servers, different services. So that's where that comes in. So let me also, and by the way, I think we have both chat and Q&A here. So maybe let's monitor both. I see one question on the Q&A. What steps ensure database connection to LangGraph when building CoAgents in production? Are there any helpful doc regarding the setup? I was reading the docs and couldn't find anything related to deployment, e.g. AWS. So we'll get to that. I think hopefully during the demo, things will clarify a little bit. And happy to dig into this also afterwards. So let's, I'll leave this to the Q&A session at the end. All right, so let me share this. Second. There we go. So first of all, I'm going to show you now first a demo, and then we'll kind of backtrack and see how we actually build this thing. You can find this demo, it's open source. So if you go, for example, to our documentation under CoAgents, and now you're in the CoAgent section, there's all the guides here, and here is the demo we're going to show today, which is open source. I'm going to actually run this here. And so this is a research system we made here. Imagine you're a researcher, you now don't want to just do research by yourself, you want to have a virtual colleague working alongside you. So just as an example, let's say we're researching founder mode, right? Is it the best way to run a startup? And you guys might have seen this over the news a couple of weeks ago. There was a lot of communication of founder mode versus manager mode. So let's say we want the format here to be, pros and then cons, and then finally the conclusion of how we build this. And now we can ask the agent to help us out. So help me with this research. So first of all, one of the first things you'll see is it can see everything I wrote here, right? There's shared state between the agent application. Again, these are no longer two distinct systems. They're just one system. And now as the agent is doing things, we can see what it is doing, right? So searching for the founder mode, searching for the advantages of founder mode in startups, and so on. And the advantages, disadvantages, effective, non-effective. Now, after it researched it, it's now finding the resources that it actually wants to use. And I can see them here and edit them here too. Right? Let's say I don't want one of these resources, I can just delete it and everything gets synced up automatically. And now it's actually writing the research draft. And you see it's following the format that is laid out for it of pros and cons and conclusion, because it could see what I was already working on. So this is kind of the demo here. And of course, we have both this conversation with an agent as well as everything that's happening here. And we can now, if we wanted to, in a real situation, continue to iterate with the agent until we get something really great here. So this is the kind of basic setup here. And let me actually share my entire screen here to show you how we actually build this. Set something up before. Let's see if I can get this again.
We're getting a few questions right now. Do you want to?
Yeah, we can. Is it
first?
I'll let you judge, maybe, because I can't read and talk at the same time. Should we talk about them now or wait until the Q&A?
Let's get to them. Let's get to them later.
Okay.
After you jump into the code, but I just want to point out that these features allow for behavior that is really what the user is expecting. Like a tie set up some structure for how the research should be conducted, and you didn't have to prompt it in the chat to the agent. The agent was just aware of the structure that you laid out and of the question. And yeah,
that's
both
right.
directions. Yeah.
And so at the root of this thing, of the application is this LangGraph agent, which is pretty simple. You can see here in LangGraph Studio how we're visualizing it. It starts by downloading the resources if they're needed. That's the first step because the user might have actually added resources manually. Then we go to the chat node and we can either search for new nodes, delete a node. It's actually a flow that I did not show. I can actually show it really quickly here. Let's see. Where's the other screen? So let's say we want to delete, the 3 worst resources. And it's proposing us which resource we want to delete. Say, yes, let's delete these 3. I don't like them. Great. And so this is the human in the loop flow in the agent, and which is just a few lines of code. We have the delete node here, of course, and then perform deletion. And this is just plain LangGraph code. So if you go to our source code, you can dig in here. It's split into an agent folder and a UI folder. The agent folder is completely straightforward, standard LangGraph code. Nothing fancy going on here. And you can see here, if we were to run this, we say, let's say we add a message of, help me research founder mode versus manager mode. This agent is now, off to the races. And so this is the basic structure. Now, what we start with here is this application that switch back to where it was originally. I think it might have been a different window. Here, let me just rerun this. You can actually even see this. We have poetry. We just run the agent code. We just run poetry run demo. That's all it takes. And then for the UI, we just run pnpm run dev. So that's all it takes to set this up. And all right, now we have this open here. So we're starting with a native application that is, there's no chat here. There's no AI agent native capabilities. And yeah, you can add resources, you can use the application, but we again want this virtual colleague at our side. And so the first thing we're going to do is in the agent application, we're going to go on into the page.typescript and bring in our Copilotkit wrapper. So now we wrap our application with a Copilotkit context. And you can wrap the whole application, or you can have just parts of the application where you want agentic behavior. And we pass it a runtime URL, which is where we host our information, as well as, in this case, agent lock. We're locking the Copilot to one agent. There's other modes you can use Copilotkit with. You can have agent lock, or you can have router mode. Router mode will kind of route things to the right agents, sub-agents as needed. In this case, for simplicity, we're just locking everything to a single research agent. So now we have this context. Now we could now add anywhere in the application agentic chat and non-chat experiences, and it will just work. We have both headless UI, so you can just write everything custom from scratch, but we also have these built-in chat components. In this case, we're going to use Copilot Chat, which is really simple, and we're customizing it. You see here with just simple CSS. In our documentation, there's actually, maybe I'll just show this really quickly, a section for how you customize the look and feel here. And you can, again, both do fully headless customization. You can pass custom components, or you can just pass in different CSS, and you can see here everything. It's really nice, shows you how to do that. So, okay, now we have chat here, and it actually just works. So we can chat now with the LangGraph agent. We can say, hello, and it'll talk back to us. All right, so now let's actually start integrating this properly. So we go first to the research canvas. And the first thing we're going to bring in here is use CoAgent state. And this is, and wishes to replace the normal use state of React. With use CoAgent, sorry, not use CoAgent state, just use CoAgent. When we call use CoAgent, we get the set state and a get state, which are standard React variables. So these are staying automatically up to date as the agent state evolves. And we can initialize it with an initial state, in this case model, because we have this model selector. You can use different models here. And so now we have agent state plus shared state. So if we ask it here to, conduct the research, research founder mode versus, manager mode, let's say, we can see it's going to do a bunch of work, and this is going to spin for a while, but eventually we'll actually see this state here updating in the application. Now, but what do we get? We need to actually make this, and you guys are probably familiar with this. If you guys are building, trying to build agent applications, a lot of these kind of look like this, kind of like demoware, right? It's loading, 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 and eventually you get something, but this is not something you can actually ship to production with users. And so, and you see here, we have got the resources updating, and soon we'll also have the research draft, but it's kind of all in one. And the reason is that the state of the agent only updates across node transitions in the LangGraph, right? If you guys are familiar with LangGraph, you know that the state of the agent only updates between nodes, but we don't want it to only update for the user between nodes. So we want continuous state transitions. And so that only takes, again, a few lines of code. If we go under agent, we have a few places where we can emit continuous state to the user. And so one of these places is right here in the chat node. We're going to emit the research draft continuously as it's happening. So that we're intercepting a tool call and emitting and treating part of that arguments of that tool call as additions to the state. And the CoAgents extension naturally syncs everything back up again when the actual state changes at the end of the node. So it's all pretty neat. We have the same idea here in a few other places. So we're going to bring in Copilotkit emit state. And we're going to do the same exact thing here for the resources. So we want the resources as they're getting written to continuously update the state. And you can see it just takes, one line of code. You specify the tool, which state you want it to update, and so on. And then finally here, we're also going to update the state. Let me make sure I got all of these places. I think we do have a couple more. So this is Copilotkit emit state for the downloading of the resources. So I think now everything's working. And if we try again to research, founder mode versus manager mode, we'll see, well, at first, we're still just in loading state. We haven't yet added agentic generative UI. But we will see that it will actually start to update the state automatically when these things come in. So you see the resources are now coming in continuously. And the research draft, when that's ready, it'll also start to ring in here. So you guys are probably familiar with these kind of like demo-like appearances versus something you can actually ship to users. So now we're actually ready to add in the UI code here. We're ready to add use CoAgent state render. So this is going to actually render what the agent is doing as it's doing it. And in this case, and you can pass an arbitrary React component here in the loading indicator. So now we actually retroactively see that it was downloading these resources, right? And if we now rerun this agent and, research manager mode versus founder mode, we're seeing that we actually can see what the agent is doing. It's searching for different things. This is actually something you can actually ship to real users, right? The users can see what the agent is doing. It's also building trust for them. It's not just a loading indicator. And like I said, soon we will have agent steering that will be coupled with that as well. And so this is, you see, that's all it took to add this one React hook, use CoAgent state render. which takes the full state of the agent as input and returns a React component as output. And lastly, the last thing we can add here is the human in the loop capabilities. So for human loop, we're defining
let's pause here for questions before we jump into human in the loop.
Sure.
Yeah, because there's a lot there. You can keep the code open. I think that'll be good.
Okay.
So Thomas asks, can you talk more in detail about how the state is shared? Is it accessing the entire React state? How does it know which subset of the state to use?
Yes, and actually, let me see if I can quickly open here a visual that we just made to explain this. So this is not on our website yet, but I'll share it just straight from Figma.
And if anything was unclear, please ask now. It's a good time. And this will be on our YouTube later.
Yes, let me share this 1 second. Great question, by the way. Okay, so I'm sharing now. Let me guys know if you can see this. Can you see the illustration here?
Yep.
All right, great. Okay, so the question was, how does the shared state actually work? Okay, so what we want is, again, the state of the application to be the same as the state of the agent. And we want an additional thing. We want the state to be continuously updating, because as you guys saw, state is the right abstraction for thinking about agents and what the agent is doing. So that's the thing that you want to keep in sync. And it's simple and it's developer friendly, but again, it updates this continuously. So what CoAgent extension does is the LangGraph agent emits discontinuous state updates as it's going along, right? So between each node transition, you get a new state update. At the same time, it's emitting continuous data streams, right? Everything that you're doing, every tool call, you can emit continuous data streams from the agent. Now, what we're doing is we're unifying the relevant parts of these things. Okay, so we're taking the discontinuous state updates and the continuous data streams, and we're constructing out of it a single continuously updating state object. And which is what you want to essentially reflect to the front end. Now, before you actually reflect it to the front end, you want to project it securely, because not every piece of state in the agent you want to actually reflect to the user. So we project it securely, and then we efficiently transmit only the deltas to the application. So this is how the state makes it into the application. And the other direction, it's a little bit simpler, but we provide essentially the React state has its own piece of state. And then when you every time you rerun the agent with a new state, it sees not only the updated state, but actually also sees the previous state and the delta, as well as a hint that you can programmatically provide about why something might have changed. So that helps the agent figure out, where's the user trying to take this application. You're not just starting from the current state; you're kind of seeing the trajectory there. Hope that answers that. Did that answer the question? All right, will we move on? Are there other questions? I also see we're potentially at time for another few minutes.
Yeah, so we can get to the other questions at the end.
Okay. I do see we're a little bit over time now, so hope we're going to continue for another 5 minutes here. But this is kind of the essence here. We rebuilt. You saw us rebuilding this application from scratch. So I think really questions is actually this is the right time for questions. Uli.
Yeah. Okay. So you can open the chat, right, to see the questions?
Yeah. Okay. So let me go through those. Can you talk in more detail about how the state is shared? Okay, that's what we just covered. Which particular section in the code framework is trying to research which action to perform tool to use based on the user question? Does it use React or Rewu pattern? So great question. Thank you, Ken. So this is actually based fully on what the LangGraph is doing. So in this case, it's a React-inspired approach, but it's not strictly React. Let me share the code here again so you can see. So in the agent we're constructing a standard LangGraph agent. So we start by adding the nodes. We add the edges between the nodes, and then we add one conditional edge in this case from the chat node that can go either to the search node or the chat node or the delete node. And it's based on this routing function we'll decide, and it's kind of seeing, what the user is currently doing to decide what to go next. And actually, one very important thing that I did not show is to get human in the loop. That's all you need to do is add an interrupt between two different nodes. This is a standard LangGraph interrupt. This is all standard LangGraph code. Yeah, you essentially get that for free on the front end side. It will actually, I can show this specifically here. We have the delete node here, and then the perform deletion node. The delete node, the perform deletion node will look at the previous messages to see the content of the response from the front end action. Thanks to that interruption, it will actually cross over before it goes back to the agent code. So I hope that makes sense. And by the way, again, happy to dig into all of this on our Discord as well, if somebody wants to kind of dig deeper into any of these questions.
Yep.
And let's see, can I run this on Kubernetes or Dapper as an actually distributed on yes, or on one pod? Yes, you can actually run this distributed. So we introduced a Python SDK for remote endpoints in Copilotkit, and you can run this anywhere you want. Let me show again the code here. So the question was, can we actually run this distributed? And the answer is yes. So if we go on the code again, we see that we define here the Copilot runtime, and we specify a bunch of remote actions URL. This is actually misnamed. It should be remote endpoints, but we're a little bit stuck with this name now. We'll maybe have a transition. But in any case, we're passing in this URL, and in this case, we're running locally, so we're just passing, the local host URL. But this can be on any remote server, and so you can run the agents anywhere you want. We're actually also going to be introducing LangGraph Cloud support very soon, so you can run that on the LangGraph Cloud node as well. Yeah, that's the essence. But you can also fully control where this runs. And maybe
we have sorry, keep going. We have another question from the Q&A afterwards.
Got it. Okay. I can just show really quickly here, when you initialize on the remote endpoint, that's all it takes. You have a fast API endpoint that you can add on to. You can have your existing fast API. You initialize Copilotkit SDK with a LangGraph agent. You give it a name and a description, and then just pass the graph object as is from LangGraph, and then you finally add this API endpoint under, in this case, /Copilotkit. So yeah, this can run on any server anywhere you want. Okay, so another question here. Are these WebSockets or similar? I noticed in the demo it's using a web URL. Is it polling mechanism? Great question, Bobby. So this is based on WebSocket under the hood. So yeah, fantastic question. And it's continuously in communication while the agent is running, essentially. And then there's a stateless abstraction across agent runs, essentially. So every time you start a new agent run, that's a session that has a continuous socket connection all the way to the front end. And this actually goes first to the Copilotkit runtime and then into the front end, which gives you a lot of power and efficiency, of course. Can we feed this data as arguments to a function call? Yes, you can do that. So you can actually just do that, by default. This is just a standard React state variable. So again, maybe I'll just keep this open, but actually it's hard for me to read the text otherwise. But on the React side, we have, again, use CoAgent as the abstraction, and you just get a piece of state. So you can use this state however you want. So if you have an action, in this case, the action has render and wait. There's a few different variants of these use Copilot action. Render await is the right variant for human in the loop, because we actually want to render some state, and then finally, call a handler when the user clicks a button, yes or no in this case, right? So it's also very straightforward to do this, but you can also pass a handler here and just execute an action on the front end, and there's actually the exact same abstraction for backend actions and remote actions as well. Now you can use the state here. You don't have to use arguments that are passed into the action in this handler. You can also just, if you wanted to, use the state of the agent. So the answer is trivially yes, without needing to do anything unique to support that use case. So let me go again to the questions. My question is, if we're using Copilotkit on external Python service, so why we initiate an OpenAI on the front-end server API? I'm getting confused. Great question, Hamdi. So actually, first of all, none of the there's no OpenAI request initiated from the actual front end. So what you might have seen here in passing was the Copilot runtime, which is its own lightweight stateless backend that powers Copilotkit. And that can make requests to an LLM if you're not in router mode. If you're not in agent lock mode. So in agent lock mode, it goes straight to the agent. But like I said, you can also use Copilotkit in router mode. And then you can actually have different agents for different use cases. And some of that routing abstraction goes through an LLM, and you can use OpenAI or any of the other LLM providers. We have LLM adapters for many of the big ones. We also have a LangChain adapter. So any of the models that you can use through LangChain, you can use through the LangChain adapter. And so that's where that's used. But generally, everything goes through the agent itself. That's when all the agent interactions go through the agent. So great questions. Let's see, a bunch more questions here.
And we're like 10 minutes over time. Let's let people go, and whoever wants to keep hanging around for questions.
Yeah. So I guess only closing remarks again is we're really excited about this. We got really strong response for folks building agent native applications. Once again, to plug the hackathon, we have a hackathon this coming weekend in partnership with AI Thinkers and with Google as the premium sponsor at the Weights and Biases offices in San Francisco. So if you guys are in San Francisco, please join us. And we'll just drop the link here in the chat. Thank you for that. And I'm available for offline to take things further as well. And I would love to hear from you if you guys are building agent native applications.
And we'll send an email or a blast at the end of this with all the links. This will be up on our YouTube. We'll send the links to our Discord where we can chat.
Yeah. And I just see here some other questions. How does it sync with current solutions of different LLM providers? Yeah, so we support any of the LLM providers. So with the agent, it just use LangGraph. You can use any model provider there. And then everything that is outside of the agent, we have an LLM adapter abstraction that has support for any of the LLMs out there. How to complete headless fashion without depending on React UI library? Great question, Ken. Thank you for this question. So everything you can do from the native UI, you can also use with a headless UI, and I can share in the documentation what that looks like. So let me go here. We go to docs.copilotkit.ai. We go here. Let me move this out of the way. We have, if you look at custom look and feel, there's also headless Copilot UI. And here you see there's a use Copilot chat abstraction that gives you everything you need to build, our built-in chat experiences and a lot more. We have folks that have a voice native UX that they built on top of that. There's a lot of things you can do here. If you want to own that interaction yourself, or actually extend it, there's a combination you can do here. I also see a question about the LangGraph JS on the roadmap. Yeah, so actually we should have LangGraph Cloud support and LangGraph JS support through that and through something else on that horizon, on that roadmap in the next couple of weeks, essentially. So if you guys are waiting for that, that should arrive promptly. And if you want early access, we actually We do have an early access program for that as well, for folks who want to kind of test it out in the early phases. So let us know if you want that. I also see a question: what steps ensure database connection to LangGraph when building CoAgents in production? Are there any helpful doc regarding this setup? I was reading the docs. So I'm not sure. I think I probably answered that with a socket question. It's not a database connection. It's just it's a socket connection to a LangGraph agent. Yeah, so I think that was answered. And then trying to find here the chat again. Chat, there we go. All right, I think we answered all the big ones. If I miss your question, I'm sorry about that. Please just hit me up afterwards on the Discord or elsewhere. And yeah, really great to have you guys here. Yeah, look out for the email afterwards with a summary recording. We're also going to put kind of a shortened just code walkthrough of this thing online that you guys can look at. Yeah, that's all.
Cool. All right. Thanks everyone for coming, and yeah, be on the lookout for the message afterwards.
All right.
All right. Thanks
See you guys.
everyone.
Bye-bye.